Alright, this is part 2 of the RTS unit tutorial, and today's lesson is agents. So instead of using a lot of Unity's physics and stuff for movement, which I do use some physics, what I do is I attach an agent object to each unit, and then I implement a bunch of different behaviors. So as you can see, if I click on these guys in the spec, there's like 4 different movement types attached to it at the same time. So just like we have all those different behaviors for the state machine, this allows us to attach different movement behaviors so we could seek a target and also avoid obstacles at the same time, like you just saw in my MS Paint presentation. So we're going to create a class called steering. Now steering holds 2 different things, angular rotation and a 3D vector that represents velocity. So it's going to be your instantaneous displacement, how far you move from one spot to the other in a single frame, and how much you rotate in a single frame. So we're going to call those 2 values angular and linear, and then we're going to create a default constructor that just initializes both of them to 0. And this is going to come in handy later. As always, here's the code up on the screen, free to copy, and it's going to be on GitHub anyway, so if you don't want to copy, just sit through this cool music. Alright, now we're going to create a script called agent. So this is what is going to take that instantaneous velocity and apply it each update to update your position. And this is going to handle all of the different behaviors that you apply to it, all those different steering methods that you create later on. So we're going to create a value called max speed, that is the fastest that your agent is allowed to travel. True max speed is something that we might end up using later if we get into group formations. So if you want to match the speed of somebody else in your formation, you're going to take their max speed. So you're going to need a true max speed so you can reset. Max acceleration, it is the fastest that you can accelerate every single frame, and I didn't set it. That comes in later in the video where I encounter a bug. Orientation is your total rotation in the world about the y-axis or whatever the vertical axis is. Imagine that there's a stick going through you from top to bottom and you're spinning it. That is your orientation. Your rotation is your instantaneous, like each frame, how much you're going to rotate. Velocity is your velocity that you're moving at per frame. Steering is the steering that gets applied every single frame. Max rotation is how your maximum angular velocity per frame, and max angular acceleration is your maximum angular acceleration per frame. So when we start, we're just going to initialize all these values to 0 and make sure that our max speed and our true max speed are the same. Alright, so set steering is a method that is going to set the internal steering of this agent and apply a weight to it. That weight allows us to combine different steering behaviors in different ways, and we can kind of tweak them and experiment with them. So like, for example, let's say you're chasing a target, but as you approach a wall, you want to avoid that wall more than you want to chase your target. So the steering weight for that avoid wall steering behavior is going to be a lot higher. Okay, so in update, we're going to actually perform our physics calculations. So we take our rotation and we apply it to our orientation, and we take our velocity and we apply that to our game object's transform. And we also limit certain things, so if our velocity is too high, we're going to cap that. If our angular velocity is too high, we're going to cap that. Notice how I've done a couple things. I have locked the displacement of the y-axis to 0, and I've also made sure that rotation only takes place along the y-axis. This is for my game where I want things to kind of behave in a 2D space almost. If you want people to walk on walls and stuff, you're not going to have that. Another thing is multiplying my velocity times time dot delta time. That makes sure that my velocity isn't tied to the frame rate. So it's always going to be calculated based off of the elapsed time of your computer, not based off of frame to frame. So our position gets updated by our velocity, our orientation gets updated by our angular velocity. Then we reset our velocity and angular velocity to 0 and move to late update. The weighted steering behaviors all get added together and update our internal steering variable. Then we take the values from that internal steering variable and update our velocity and our angular velocity, and then we clear that internal steering variable by setting it to a default constructor. These will get applied during the next update on the next frame. So all of that is just to explain what this late update function does. You'll notice that we also cap our velocity and angular acceleration. I cap the velocity using that normalized function for vector 3's. I messed that up. It should say if velocity at a magnitude is greater than max speed, not less than. Next, we're going to add a way to externally reset our max speed. This isn't going to be used in this tutorial, but this will end up coming in handy whenever we get to the flocking and voids tutorial later on. Okay, now we're going to create a new script called AgentBehavior, and this is going to be what actually defines our different steering behaviors. It has a couple of virtual functions, which, if you don't know what virtual functions are, they're functions that allow you to override them when you have another class that inherits from the parent class. So we can easily implement different steering behaviors within the same framework by using these virtual methods. If that doesn't make any sense, it doesn't matter. I'm going to show you what to do. The first thing we need is a weight, so that we can weight all these different steering behaviors differently. Then we're going to need a reference to the target in case we're pursuing something. Everything is going to need a reference to the agent so that we can apply these steering behaviors to the agent. One other thing we're going to need is a vector3 as the destination. If we're not following a target, if we want to move to a location in the world, then we would use a vector3 destination rather than a target. Next is the max speed and max acceleration, and then we're going to have the max rotation and the max rotational acceleration, or angular acceleration, I guess. Alright, so when we start, we want to assign that agent, and then every single update we're going to apply the steering from our behavior to our agent. This next part is just to clamp our rotational values. I don't cover it at all in this tutorial because I don't do any rotation because the object that I'm moving is a ball. I might get to it later. Okay, last is get steering. Get steering is the secret sauce that allows this to be so powerful. All it does, right, the virtual version, is create a new steering function. But if we make another class, we can override it with whatever we want, and then that allows us to define literally any type of movement that we want as a steering behavior. All right, so now create a class called Seek. This is going to be our first concrete steering behavior. It's going to inherit from the AgentBehavior class. Make sure that if you spelled AgentBehavior without a U, like the British spelling, you omit the U. I think Unity always corrects it to have a U, and it messes me up every single time. All right, so what this steering behavior is going to do is it's going to move us towards a target by taking the difference between our position and their position, normalizing it, and then multiplying it by the max acceleration. Then we just have to return that, and that's all that we have to do. This next part requires scripts from the last video, so go watch that if you haven't now. Alright, so now we need to go into our base behavior script and make sure that we have a place to attach our agent script. Also make sure that we have a place to attach our seek script, and make sure that we set our max speed. And on start, we're going to need to instantiate that agent script object and set its max speed. Okay, so now in that seek behavior script, we're going to make sure that whenever we start up, if there's not already a version of the seek script attached, we're going to attach that seek script. So we're just going to attach it, and then it's going to do its thing. We also want to make sure that when the seek behavior, I realize that these naming conventions are confusing, I apologize, but when the seek behavior gets destroyed, we destroy the seek steering behavior. I really should have thought about naming these before I made this video. You're going to need to set your max acceleration if you haven't already, otherwise this won't work. Sorry, I forgot about that. But you'll now see that when we change states in that state machine, we follow the box, which, I mean, that happened before. So what's the big deal? Well, here's the big deal. We can define different steering behaviors super easily now and just attach and detach them the exact same way that we did with our state machine. So let's define a new steering behavior called flee and just make it the exact opposite of seek. Instead of going towards an object, we run away from an object. All we have to do differently is attach this behavior instead of seek, and all of a sudden we have a completely new thing, right? So rather than having switch cases and if statements that determine what we're going to do, it's just attaching and detaching components. And the beautiful thing is we can attach as many of these as we want at a time, as long as it's within reason. So now if we apply some weighting, we apply 1.0 and 1.0 for flee and seek script. If we apply this weighting and we run the game, we'll see that when we go into seek mode, nothing happens because the weights are equal to each other, so it's trying to run away and go towards the object at the same time. If we adjust the weights, let's say that we make flee 0.7, now seek starts to take over, right? But if we make seek weaker than flee, it'll start running away. So you can combine, I think I have like 5 different steering behaviors in my units in my game combined at the same time. Alright, so I realize that these last two videos were kind of some boring groundwork, but they're very powerful methods that allow for the higher level things that we're about to do. So we're going to do some voids and the flocking behavior and the fire team organization and formations. But before we did all that, we needed to implement these so that it makes our lives a lot easier down the road. Anyways, thanks for watching. Let me know if you have any other ideas for tutorials that you want, and I will do them. It might take a little while because I got work and stuff that I have in the meantime. But anyways, thanks for watching.